we can make a real class out of this. Oh, and let me do my normal thing. So let me just, oh, and the chat started all over. So I'm just going to do it this way. Good morning, Vivian. Good morning, Charlie. Good morning, Jayla. Good morning, Noel. Good morning, Julian. Good morning, Lakshmi. Good morning, Alyssa. Good morning, Soad. Good morning, Daniela. Good morning, Farouk. It is great to see you all. Okay, we are going to go back to physics now. And stop me again if, oh, you can't see. Sorry. Can you? Oh, wait a minute. Can you even hear me? Oh, sorry. Hold on. Oh my God. That's bad. Okay. No. Oh, okay, sorry. This is now becoming a bad Pink Floyd album. Bear with me. Hold on. Okay, we're gonna try this one more time. Can you guys hear me? Yes. Okay, cool. Okay. And you, not to be weird, but also you can see me, right? I mean, and you can see the board. Yes. Like it seems almost normal now. Okay. Okay.
Yes.
All right. Thank you again for indulging me. All right. All right. Okay. So we're gonna go back. So again, stop me at any moment with questions. Again, we're just going to go back to going over this homework. We're going to hopefully get off homework 1 today finally and get on to homework 2. I believe I'll try to go faster today, especially since we just lost time now also. And I think we're up to part 3. Parts that make you think. We're at part 3. And we are at question. Okay, we're part 3 and we are question. Oh, thank goodness. We only have 1 question left finally. Oh, okay, wait. All right. We are totally in class now. Okay, all apologies and spazziness now putting aside, I have to say something. Right, we're at part 3 and we're about to be at question 2 of part 3, i.e. finally the very last question of this sheet. And believe me, I want to get past this sheet as much as you do. One thing I'll say quickly. You might have noticed when I posted the notes from Monday's class, I don't know, maybe I should ask you, maybe you want to confirm or deny in the chat. I posted the notes from Monday's class. Then I realized a few hours later something, and I reposted the notes. Like I posted corrected, updated notes where I corrected the very last page of the notes because, and I don't want to get too bogged down in this, and I certainly don't want to stress anybody out, but everything, when we went over question 1 of part 3 last time, like all the logic of everything I was saying was correct. But as it turns out, all the logic I was saying, I was misremembering something about the setup of this problem. Like I plugged in the wrong numbers. And I may have really confused or bothered some people. Like, you are a very polite class. So some of you might have had a different answer from what I was doing. And I think even some of you did raise questions, but you know, I sounded like all teacherly and loud and yelly and everything. So I may have like strong-armed some of you into believing that what I was saying was right, even when you had, you know, accidentally strong-armed you. even when you had a different answer. What I'm trying to say right now is I realized hours later that I did make a mistake when I went over question 1 of part 3, not the logic, not the equations, like all the explanations correct, but I put in wrong numbers. So I corrected that in the notes, and I do encourage you to please look at those notes or make sure that you are clear. But B, particularly if what I'm trying to say is that the actual answer to question 1 of part 3, the actual answer is -2 feet. Whereas I believe in class, I was saying it was +1. So I just want to make this absolutely clear. There was an error at the end of that last class. I corrected it in the notes. And if anybody wants me to, I can back up and re-explain it now. But I'm a little worried that's just going to confuse people more or frustrate people more or whatever. So just please know the actual correct answer for question 1, part 3 from Monday. The actual correct answer is position equals -2 rather than +1. And the math and everything has been corrected in the notes. Can I just get confirm? Okay, so let me look. Can I get confirmation or denial in the chat that you understand what I'm saying now? Am I making sense? Can anybody confirm or deny whether they saw that in the notes? Yes. Okay. Cool. Okay. Thank you. All right. So I'll just leave it at, all right. And so you're cool if I just, okay. Well, thank you for understanding. All right. So again, if we ever, okay, cool. All right. So now I'm going to move on to, so I apologize. This is quite a week for Yaverbaum. So now we'll go to the very last question of the sheet. Part 3, question 2, and what we want to know here is right. So here for this question, we want to know for t equals 3 to t equals 7, what's the average velocity, right? So we're finally asking about an average velocity for some sort of, as it says, intermediary chunk of the journey, meaning that this is a piece of the journey where this is not the challenge of this question. The reason that this counts as a problem in which you must think, and again, it doesn't mean it's impossible or unfair, but just where you might have to think a little bit. The principle here is that the interval of time that we're looking at is not one of those constant velocity segments, right? I mean, or just to summarize, notice in this whole problem, first we go at a constant velocity in one direction, and then we go at a constant velocity for another section, and then we go at a constant velocity for a final third section. So each one of those sections has some sort of pattern or reliability or predictability to it. And that's why whenever we're doing our analysis, we like to sort of apply our analysis to one section at a time. For each section, we have a particular velocity that applies. Here in our final question of the whole sheet, we're being a little bit more tricky and saying, oh, let's look at a piece of this whole journey that kind of includes a little bit of more than one constant velocity segment. So that's the sense in which it's meant to be more challenging. However, if we just do our usual procedure, okay, we're being asked what is the average velocity. So what's my first step? Okay, so I already drew the diagram. Let's say I've written the question here. So I do my third step, which is write down a general definition or principle. That is, I remind myself that average velocity in general is displacement over time. Like that's the equation, so to speak, the definition, right? So now I'm going to say, so I always do that before I plug in numbers, but here now I'll plug in numbers. Here I want the numbers. Okay, here I know t equals 4, right? Like the time is definitely 4 seconds from 3 to 7. X naught means, and this is kind of like what I was saying in Monday's class, X naught means the very first position, right? The position when time equals 0, but for whatever particular experiment or section we're looking at. In other words, X naught here means X at t equals 3, right? I hope that's clear to people. Oh, sorry, that is not. X naught means X at t equals 3, the very first x that we experience for this segment. And at t equals 3, we're told by the problem that that is indeed -2, right? So the only other fact we need in order to figure this out is what's x, the final position. And by that, we mean what is x at t equals 7, right? Now, that would be a hard question, or that would, like, that is not just told to us in the givens or whatever, but we just spent all of this time in question 1 figuring it out, not coincidentally. So we know, and that's the thing I was just referring to. So we know that at t equals 7, x happens to equal -2, right? So those are all our facts of the problem. So just to finish it up on the next page. So if v equals this, okay. So I believe the final answer to the end of this whole sheet, finally, we're done with the sheet. I believe the final answer to this is 0 feet per second, right? That's not the average speed, but the average velocity for this weird little section that we're looking at is 0, because if we think about it in this section, it happens to be a section that takes the instructor from position -2 somewhere, but then back to -2. So he ends up not being displaced at all for those particular 4 seconds. So the answer is 0. So I think that's the answer to the last question. I think that's the end of the sheet. I am sorry once again that it's taken me so long to go over the sheet, but hopefully that's clear now. And we can, so I'm going to move on finally to the next sheet. Soon I'll start posting some more homework and catching up with yours, but I'm going to move on to the next sheet, which is called average speed. I'm going to race through some of the problems, but I'm going to spend a little time on I think there are some hard ones at the end that are harder than they look. But while I shift gears and go to the next sheet of average speed, please look and see if there's any questions at all you want to ask about any of this. Like, this puts this to bed finally. This puts to bed in principle. Like, in principle, when we're done with the sheet, we understand distance versus displacement, and we understand average speed versus average velocity. Like, those are supposedly the takeaways from this sheet. And as far as equations, we have one equation that we get from this sheet, which is v bar triple equal sign x minus x naught over t. In fact, let me just read. So please just take a moment or take a breath. If we're going to spend this long on the sheet, make sure you're good with me moving on. Okay, if I had to summarize the findings from that whole sheet, it's what's in blue at the bottom. Distance versus displacement, average speed versus average velocity, i.e. scalar quantities versus vector quantities. And then the one and only one equation really that comes from all of that is average velocity is defined to be displacement over time. That's what I think we get from that sheet. I'm going to move on to sheet 2. Going once, going twice. Okay, going on to sheet 2. Okay, so so trying to move on a little bit here, to move a little faster. What I've just given, just to be clear, like I've given what I believe are the correct answers to the first three warm-ups. I'm kind of now trusting. I feel like they're not meant to be too challenging, these first three warm-ups. Again, if you're handing in homework to me, you actually have to show more work than this, right? As annoying as that is, I do expect more thorough solutions from you than this, but you know how to do that at this point. So just to make sure that we're both on the same page, these are what I think the answers are to the first three. You basically are just plugging and chugging the definition of average speed, but just a couple of, so please, so, I mean, if you got those answers, good, great, we're both on the same page. If you don't have any questions, great, we're going to move on. If you do have any questions, please do ask. Just note one thing. I mean, yeah, just note, first of all, that any units, I mean, we ultimately like the metric system and all that, but you know, whatever units a question is phrased in is what units the answer should be phrased in. Like whatever measurements you make in the lab is then how you present the findings from those measurements. So just notice, like the first answer is in miles per hour. That's totally fine. That is a legitimate set of units for average speed. Like as long as it's a distance over a time, that's legitimate units for average speed. And I'm not trying to, I don't have to convert just for the sake of converting. Then notice in the second example, even though there's three breakdowns, I just do want to, like, even though the car clearly stops a number of times, it doesn't matter. The average speed is still just literally the total distance over the total time, even if zeros are included. I'm just trying to sort of call that to your attention. And then the last one, you know, if average speed equals distance divided by time, then distance equals average speed times time. We saw that in the last sheet. I don't think that's surprising to anybody. And the number for the last one is realistic if you care, or if you know, that is in fact how fast light is, which is pretty fast. Like for perspective, if you, I'm just gonna say this just for perspective, you know, the earth is round, like duh, but that's not a duh actually, but the earth is round. We believe the earth is round. But if you took, and light does not travel like in a circle, it travels in a straight line. But if you took the entire circumference of the earth, this is just for perspective, a little side note to keep everybody paying attention. If you took the entire circumference of the earth and sort of unwrapped it and made it into a straight line, like, which is what the idea of circumference is, like picture the length that it takes to walk around the whole earth, that's approximately 24,000 miles, just so you know. 24,000 miles is how, you know, if you walked around the equator of the earth from New York City all the way like through the Atlantic Ocean, through China and back to New York City, that's 24,000 miles. So just for perspective, that means that the distance that light travels in a second is almost 8 times that. It's a little bit more than 7 times. I mean, because light travels 186,000 miles in a second, but the whole earth is only 24,000 miles. So light could go the equivalent of the entire earth's circumference almost 8 times in 1 second. That is staggeringly fast. I mean, in other words, there's no you could stand as far away from someone as possible on the surface of the earth. And the most time that it would take light to get from you to somewhere else on earth would be a 16th of a second. Like, no wonder we all think light gets there instantaneously, if you know what I mean. Like, no wonder it took centuries and centuries and millennia for people to realize that light actually travels at a speed at all. Forever, people thought light just got there. It, you know, that it traveled at infinite speeds, because it certainly seems that way on the surface of the earth. It is that fast. But anyway, all right. If there's no questions, that's the warm-ups. They are just warm-ups. But now, and I'm making sure there's no questions. Okay. But now I think it gets a little bit more interesting with the next problem, the HillFigure problem. I think this is worth talking about. So here I'm going to be a little bit more thorough. I'm going to draw a diagram first. Right. Well, actually, oh yeah, no. Right, okay, it's kind of a bad drawing, but here's my drawing, right, just to be clear, like this car goes up a certain trail and it goes on average 40 miles an hour. So I put that the average, I put like absolute value of average velocity is 40 miles per hour. In other words, that's one way I could say that the speed is 40 miles per hour on average. Then it comes down on average at 60 miles per hour, right, as it says, and we're not supposed to worry about turnaround time or anything like that. We're just like, we've got an up trip and a down trip. And then the question is, right, okay. So that's the question. Now, I've mentioned this before in class, but to cut straight to the chase, I'm going to tell you right now, the answer is not 50, right? That doesn't tell you what the answer is, but I want to start off by, oh, thank you. Wait 1 second. Oh my God. Okay, wait. So someone, thank you, private message. I understand. Huh. So there's, but I assume, okay, there's a private message. So I'm not gonna say the person's name, but I assume this is public information, right? Can I address this in class? So private message person, can I address what you're saying in the, because, wait. Yes, okay, thank you. So, okay, so one of you just told me that there's a lockdown in school right now. And I was about to say, okay, yeah. So I was about to say, oh my God, okay, so what does that mean? What's happening? But then the private message person wrote, no one knows what's happening. Okay, so what, so you don't know, are we, I mean, are you supposed, okay, so I'll pause for a second. I mean, if we've, and I know most of you are in school. I know not all of you are in school, and I'm not, but I understand that most of you are. So we have to do whatever we have to do. So are we, is this like a, are we supposed to lock down? I don't even know what that means. Does that mean you're locked in?
Yeah, like the gates are like down.
Thank
Like I was in the
you.
cafeteria and like they pulled the gates down.
I can't hear you if you're on. Oh, the fire alarm is going off. If the fire alarm, all right, wait. If, all right, no matter what, we obviously should remain calm, but I'm totally hearing you and I'm sympathetic. So if you're supposed to, if you're, so let's wait instructions. If you're supposed to leave, which is totally possible, if you're all supposed to get your stuff and get out of the building, then I get it and we will stop. Even, I mean, I know some of you are not in the building, but if you're supposed to get out of the building, we will stop. But maybe just one of you should tell me and we'll just pick up on. Let me see. Um, is a fire and the fire alarm is still going off right now, or yes? I mean, if the fire, um, Is it still, is the noise still I mean, usually right after the alarm, they make an announcement. They either tell you to take it seriously or they tell you not to. Who? Such a crazy. Is it still, is the noise? You could also turn off your mutes if that would help, but. Oh, they said to hang tight. Okay, thank you. All right. I know this is, oh, okay. All right. So then I'm going to keep teaching. I'm not trying to be weird. But I never know what to do. I'm going to keep teaching also because I just lost it. But to stop me again, the minute you're like, I'm just teaching because that's what I do for a living. And here we are, and it'll help us stay calm. But, and someday I'll tell you the story too of, during September 11th, I was in the middle of a quantum physics class, and it was very psychedelic that we kept having the class for a while in the middle of all the buildings were going down. I mean, I have a longer story than that, but no matter what we do is weird in these situations. But all right, I'm going to keep teaching, but stop me the moment. Oh, it was a false alarm. All right. Okay. All right. So I'm just going to keep teaching, but thank you for telling me. Okay. And yeah, I know you can never be these days, like who knows what is, I mean, the worst part is that when the Armageddon actually does come, there's not going to be an alarm, right? I mean, that's the messed up part, right? Okay. All right. So what was I saying? All right. So first of all, I think the answer to this is not 50. I haven't proven that. I'm just saying that to get people's attention. Like, and some of you did get it right. I saw in the homework. Some of you understand that, and maybe some of you don't or didn't at first. If we do this problem properly, we're going to find out why the answer is not 50. And I'm going to turn it to you guys in a second. I'm going to tell you, why am I even bringing up 50? Well, I totally get why it looks like it might be 50. It does look like it might be 50 because you're looking for average speed. So you wouldn't be crazy or dumb to think, oh, we want average speed. Let me average these two speeds. Let me just add 40 to 60 and divide by 2. That's not crazy. That is not crazy at all. But just note for the record, before we go any further, this is where like GDP comes in. We only have one equation in this class. We only have one definition so far. Our definition of average speed is total distance over total time. We never said that average speed is defined to be the average of speeds. Now, and I'm not trying to be technical and I'm not trying to be obnoxious. Like you wouldn't be crazy to think that in order to get average speed, it might sometimes work to average speeds. And indeed, sometimes it does work. And in fact, if we're super, super careful and we really think hard about what it means to average, if we average these numbers carefully and properly, we are going to find that we're going to get the right answer to this problem. But in fact, just adding 40 to 60 and dividing by 2 actually is not averaging them properly. No, you're going to see. And number 2, we never actually said that average speed equals the average of speeds. We said that average speed equals distance divided by time. And this is not meant to be a trick. This is meant to show you how serious these definitions are. So I'm going to start off by saying the answer is not 50. We're going to find, if we do this properly, I'll tell you in fact right now that the answer is 48. Any of you who got that? And there's more than one way to get it. And I'm going to show you. But I want to start by asking, just because I talk way too much, everything, is there anybody that feels like trying either in the chat, either publicly or privately, or with your voice, is there anybody that would like to say either why, is there anybody that can explain why actually 50 doesn't make sense? Is there anybody that in their own words could possibly offer an explanation why you could see why 50 might seem right, but isn't? Or if you want to offer in your own words, why the answer should be, like I'm saying the answer is going to be 48 and we're going to prove it. But whether you see that or not right now, you might see in your mind why the answer really should be, okay, it is a round trip. Good start, really good. All right, this is a round trip. But actually, you know what? And I have to put a portal in for this. You totally get points for saying that. And I mean it. But I'm going to actually go on a limb. I'm going to risk, you know what? It's not really because it's a round trip. Like, that's a great question. But the answer is, even if, like, put it this, the round trip makes it easier for us to picture. The round trip makes it easier for us to picture why someone will go slowly in one way and then fast in the other, because we're like picturing a hill. But to be honest, even if this car just went 40 miles an hour, like from 50th Street to 60th Street, and then went 60 miles an hour from 60th Street to 70th Street. Like, even if it weren't a round trip, but these exact facts otherwise were the same, I'm still going to say the answer is not going to be 50. So I actually really like that question because it does help isolate variables. But the truth of the matter is the round trip is not actually the problematic issue here. But that is a great question. So I'm going to offer again a different, but it also what Jayla just did, I think it was Jayla, not only is that a good hypothesis, but also she did just show that she totally is hearing my question. Like, my question to everybody is, if anybody wants to explain the answer, go for it if you think you got it. But even just to sort of start to conjecture why the answer wouldn't be 50, and I'll give you another hint or put it another way, it actually if you really think about it, it kind of makes sense. Even if you're thinking in terms of averages, it kind of makes sense that the answer should be closer to 40 than it is to 60. Like, it actually makes sense that the answer is slower than 50. And you can see this without even plugging in equations or anything, if you think about it a certain way. Is there anybody who wants to take a stab at that? And if not, that's fine too. I mean, okay, I don't want to put anybody on the spot, but every year that I do this, like, some people did get 48 and some people didn't. I can't remember with you guys. I mean, if every single person in the room got 48, no problem. Then of course I don't want to waste your time and over talk it. But well, I'm going to start. Okay, but stop me anytime. I'm going to say this. We want to get the average speed for the whole round trip. Even if we're thinking in our mind that somehow we should average numbers or something, the first lesson here is we always do definitions first, like, GDP. We only have one definition of average speed. So I'm going to write it down. Like, if I'm solving this problem, like, even if I don't know what the answer is or what to do, I know how to start. I start with a definition. So I write down that. And to be more specific, okay. So the first thing I'm saying is, now, again, and I don't know, by the way, if anybody wants to put in the private chat, if you want to tell me that you did get the answer is 48, or if you want to tell me in the private chat that you didn't get that answer, I mean, it would just help me to know, like, sort of who I'm talking to, or how many. You don't have to, but you shouldn't be ashamed if you didn't get the right answer. But like, if everybody secretly in the private chat told me, like, yeah, I already got 48, then I might talk about it differently. But okay, cool. That's one person. I totally appreciate your honesty. Cool, thanks. And yeah, and again, the more people that tell me that they didn't get 48, the more I'm going to not feel like I'm wasting your time. So I definitely appreciate the honesty of at least one person. Thank you. Okay. So what I'm saying here, and so here, this is an example of, like, our first, in a way, hard physics problem. Like it's a physics problem that goes against intuition. Maybe it's not meant to be a trick, but it is tricky, right? So say this were in an exam or whatever. Say you even were used to physics enough that you knew, this looks tricky. Like, this is not going to be obvious. I have to think. You might not see where to go. You might not see what the final stage was going to be. You might get nervous, whatever. But my point is, we always know how to start. We start with definitions, right? And so if we're really careful about the definition, the first thing I'm saying is that the average speed equals the total distance over total time. So in this case, that means the distance up plus the distance down which could have meant like the distance out. It could have meant like the distance north plus the next distance north. Like it doesn't really matter that it's up and then down, but distance number 1 plus distance number 2 all over time number 1 plus time number 2, right? I mean, that's just definition. That's the total distance over the total time. And that's the only proper way to start this problem. Now, the reason some of us might not have started this way, the reason some of us might have just averaged 40 and 60, even though we never said that that was a rule or we never said that was allowed, is because what's happening in people's, like I'm making this sound obvious, like just write this down. And you might be thinking, oh, well, yeah, I guess, but I don't know why didn't I write that down? I'll tell you why. Because most of you are so smart, you're thinking so far ahead without realizing it, that what you're thinking is, well, wait, I don't know the distance up and the distance down, which you don't. You don't know. I never told you the distance of the hill. You don't know the distance up at all, and up and down are the same thing. So if you don't know one, you don't know either. And it's true, you don't. And that is what makes this question hard. But here's part of the purpose of the question is just because you don't know the distance up, don't jump so far ahead to that you then make up some other formula or something, right? Which is really unconsciously what many of us do. We don't even write this down because we're thinking, I won't know what to do once I write it down, so I'll just be stuck, so I'll make something else up. No, this is the thing to write down. What do I do now? Like I don't have the distance up, I don't have the distance down, and I certainly therefore don't have the time up or the time down. So am I just done? Am I screwed? No, I've got options now. I'll tell you. Okay, hold on, next page. Okay, I'm going to go back a page for a second. We write average speed equals distance up plus distance down over time up plus time down. Now also note again, if this were an exam, notice you would get points for writing that down because it is true. Like it is totally true that average speed equals distance up plus distance down over time up plus time down. The reason a lot of people would not think to write it down is because they're already anticipating that they don't know what to do with it, like I just said. But please note for the record, you don't fall into that trap. Like even if you don't think you know what to do with this, if you just write it down, it's true and you're getting points. Now I look at it and I say, oh, but this is a disaster. Like I have these 4 things: distance up, distance down, time up, time down, 4 things that I need to plug in there, and I don't know any of them. So this is a nightmare. What am I supposed to do? First thing to recognize, and yeah, that's a concern. Like I'm going to have to think now. But the first thing to recognize, I was trying to write on the next page, is that even though it looks like there's 4 things you don't know, distance up, distance down, time up, time down, really it's only one thing you don't know. If you really think about it, if you knew the distance up, well, that automatically is the distance down because it's a round trip, they're the same. And remember, you know the speeds. You know how fast he's going up. So if you did know the distance up, you would know the time up, right? Like, for example, if it was 40 miles up and he's going 40 miles an hour, well, then it's an hour up. And similarly, if it, right? So in fact, even though we're not done or anything, even though this looks hard, we're only missing one piece of information, really. And that is the distance up. If we just knew that, we would be good to go here, okay? So again, what could be a big panic in our brain if we're not writing things down, what could be like, oh, this is a nightmare, I don't know anything, is actually now reduced to, oh, there's one piece of information that I need to get. And if I can get that, I'll be set with everything. Okay, but that information was not given in the problem. So we have options. Okay. Now, I'm going to give you two options. The first option is going to be concrete. The second option is abstract. Some of you will prefer the first option because it's concrete, but some of you will prefer the other option. They're both work out the same thing. Option one, and this may bother some of you, but option one is we say to first of all, we assume that the question did not make a mistake. Like we assume that this is a legitimate question. We're going to assume that this is an actual solvable problem, like that I didn't make a mistake in writing it. Sometimes that's not true, and that it's a problem that actually has a solution to it. Okay, it's not always true in life, but if I assume that this is a legitimate problem that actually has an answer, then that's a really important assumption. I mean, that's a really productive assumption to make, because if I assume that there's a legitimate solvable problem, then again, some of you are going to like this and some of you are going to find this bothersome. But what I'm saying is, if we actually believe that this is a legitimate problem, that it actually has an answer, and we believe it doesn't have any errors in it, then we notice that the problem did not give us the distance of the hill. That exactly seems to be the annoying issue of the problem. It seems to be the difficulty, that the problem did not tell us the distance of the hill. However, if it is a legitimate solvable problem, then in fact, the fact that we don't know, that we weren't given the distance of the hill, yet we were asked to solve for something, must mean that the final answer doesn't depend on the distance of the hill, right? Like that's a weird thing to say, but really think about it. It's got to be true. If there is an answer to this question and the question didn't contain a distance of the hill, then that means that in some way the answer must not rely on the distance of the hill. It seems like a challenge, like, oh my God, can we figure this out even without a hill distance? But what we're really saying is, oh, apparently there's a way to figure this out without the hill distance. And if that's true, if I trust that, so this is kind of like if you're looking for you lost your contact lens and they're somewhere in the house, like you might never find your contact lens because you have no idea where they are in the house. Like it's somewhere in the house, but it's so big and everything, you don't know where they are. But if you know for a fact that you lost your contact lens in the couch, right? If you know your contact lens is in the couch, you have a much greater chance of finding your contact lens while you're looking in the couch than if the couch is just one of many random places that you're looking, not actually knowing whether it's there or not. Bad analogy. But I'm saying if we know that the hill distance doesn't matter, then what that really means is any distance of hill will still get us the same answer, right? It must mean that no matter what the hill distance is, we still get the same answer. So that gives us a freedom what we can do. And again, some of you will like this, some of you will not. But either way, I'm going to give you a different method just in case you don't like it. What we can literally, but this is science. This is going to seem to you, maybe some of you like, wait, oh, okay, are we about to get like all weird? I'm going to say scientifically, if I know that result Y does not depend on information X, then that means I can use any example of information X and still get result Y. So I literally, what I can do here is I'm just looking at the time. All right, so we have 13 minutes. Now, again, bear with me. I know to some of you this might seem like, so what I'm about to say now is what we're literally going to do is we're going to make up a hill distance to solve this problem. I'm going to make up a distance for the hill. I'm going to make it up. And some of you might say, well, that's not science. That's ridiculous. Or some of you might say, you expect us to do that in the homework, just make up a freaking distance? Yes. I don't know what I expected, but yes, it's fair to expect you to do. I'm going to make up a hill distance, and I'm just going to try some hill distance that's easy to work with, and I'm going to get an answer. And the reason that's going to be a legitimate thing to do is because after I do that and get an answer, if I want, I could try a totally different hill distance if I want, and you'll see that I'm going to get the same answer. I know that going in, I believe that I can test it. So I'm doing an experiment here. I'm doing a hypothesis. Like maybe I would turn out to be wrong, but I think it's but it's an experiment that I'm going to do a hypothesis that's totally testable. I'm going to make up a distance for that hill that I find easy to work with. I'm going to get an answer. And then if I want, I can make up a different hill distance. And I bet you I'm going to get the same answer no matter what, because otherwise this question wouldn't be a legitimate question. All right. Now, again, if you don't like this method, if you think it's like cheesy or weird, I have a different method for you when we're done. But what, and that's where we'll end today's class. But bear with me, just trust me for a minute. I'm going to. Now I can make up any number I want. So I'm going to make up a number that's easy to work with. You might think the number 1 is easy to work with. It sort of is, but not that easy once we have numbers like 40 miles an hour and 60 miles an hour and stuff that are going to get involved. So I'm going to make up a number that is easily divisible by 40 and 60 and stuff like that. Like I'm going to posit a hill distance of 120 miles because technically it's the lowest common denominator of 40 and 60. Right. Yeah, now you can make up any number you want, but so let's again just go with this. This is a provisional assumption. Let's just see what happens. So if the hill distance is 120 miles, then distance up is certainly 120. I mean, if I'm saying the hill is 120, then certainly the distance up is 120. And of course, the distance down would be 120, right? And then the time up, if I'm just guessing 120, or if I'm positing 120, well, then the time up would be, I hope you would agree, would be distance over average speed up, right? In other words, the time up would be 120 miles per hour over 40. Oh, sorry. It would be 120 miles divided by 40 miles per hour, right? And the miles would cancel and the hours would flip up top because it's over hours, right? The hours. So we would get 3, right? You see what I'm doing with this? Now, again, this is all based on just like the guess or the invention that the hill up is 120. Okay, but then the time up would be 3. Going to the next page, tell me if you want me to go back, but then distance down would also be 120. Time down would be 120 miles divided by 60, right? 60 miles per hour. So that equals 2 hours, right? So then the average speed the total round trip average speed would equal 120 plus 120 over, or in other words, 120 miles plus 120 miles all over 3 hours plus 2 hours, which equals 240 miles over 5 hours equals 48 miles per hour. Now, first, I'm watching the time here. Okay. Oh, we got 7 minutes. All right. I'm gonna have to go a little faster, but first of all, I'm saying that's the answer. Now, let me pause for a second. Again, this is like a little weird. Like you might not expect this in the science class. I'm saying the answer to the problem is definitely 48 if we assume a hill size of 120. If we assume a hill size of 120, the answer is 48. You might well say, well, okay, but you just made up the 120. That's such nonsense. But look, because we're running out of time, I'll say, like, test my hypothesis. If we said it's 240, see what will happen. Like if I tried a different number now, and again, I'm just trying numbers that are easy to work with, but there's not, just because they're easy to work with doesn't mean that they have special properties or something. I can make it hard on myself if I want, but look at the pattern. If I try 240, then it's going to be 240 plus 240, right? It's going to be that much more distance. But then the times, well, if it's 240, it's not going to be 3 hours up. It's going to be 6 hours up, right? And it's not going to be 2 hours. Sorry, it's not going to be it's not going to be 2 hours down. It's going to be 4 hours down, right? Because the hill is twice as long now, so it'll take twice as much time to do everything. So if I try 240, we get 480 over 10, right? Now, you can say, all right, that's just a coincidence. You just pick 2 easy numbers to work with. But look at the pattern. Look what's happening. Whatever number I pick, like if I double the number I pick, then I double everything on top, but then I also double everything on bottom because distance equals rate times time, right? If you double the distance, you double the time. Like it's not a coincidence that no matter what number I plug in here, I'm going to end up getting 48. So what I really could do, and some of you will like this better, if you don't like this making up stuff, if that doesn't seem scientific to you, okay, let's be mathematical. And again, I know I have 5 minutes. We can do this quickly though. We could go to option 2, and you might see where this is going. Option 2 is cut to the chase. Realize, all right, fine. I don't really know what the hill distance is. And that's a bummer, but I know that it's something, and I'm going to do math on some piece of information. I just don't know what the information is. So why don't I make up a name for that information? Why don't I just give it a placeholder just so I can do the equations and see the pattern? In other words, okay, let's invent algebra. If we don't want to make things up, then we'll say let the up distance be called X. That's legitimate, right? That's the whole point of algebra and X. Let's just call it X. If we call the up distance X, then look at the pattern that we did a second ago. Then the average speed must equal X up plus X down, right? Like 2X over, and look at the pattern we just a second ago. Like it's got to be over the time plus the time, i.e. distance over speed plus distance over speed. In other words, X over 40 plus X over 60, right? If we want to be proper about this, we can just call it X, but then notice what happens. We have 2X over X plus 40 plus X plus 60. So the X's cancel. And that's really the key move right there. The X's cancel, just like in effect, the 120 canceled without us seeing it in the math here before. The X's cancel, meaning X drops out, meaning right here's our proof of our original conjecture that it doesn't matter what the size of the hill is because it's coming into the numerator and the denominator. It cancels out, it drops out. We get, and we're just about done, we get 2 over 1/40th plus 1/60th. Going to the next page really quickly, right? I mean, that's literally the answer. No matter what the hill size is, call it X. The X drops out and you get 2 over 1/40th plus 1/60th, which you know how to add fractions. You have to get a common denominator or Los LCD or GCF or whatever. In other words, I'm going to do 2 over 3 over 120 plus 2 over 120. I'm just adding fractions, but lo and behold, I end up getting exactly the thing, right? And then that flips up and what we get is like, so even if you do it totally, in other words, I didn't make up, here's, okay, we've got 2 minutes. Notice this, I think this question's a little bit hard. I think it's not at all shameful if you didn't get 48. I'm not here to criticize anybody. I'm here to say, here's why it's worth it being in physics class. The question is, it seems like the answer should be 50, but no matter how I do it, I get 48. And please notice this, I didn't make up any new formulas. I didn't make up any new procedures. I didn't steal knowledge. In fact, if you do try to make up something new, like average speed equals the average of speeds, then you actually get something wrong. All I did was very carefully apply the definition that we always had. But for the one moment that I thought I didn't have a piece of information that I thought I needed, I just called it X. And just to see what happens, like that, I just called it X to see what happens. And what happens is the X drops out and I get 48. And now with 1 minute left, let me point out why 48 actually makes sense. And I'm not trying to change a different definition of averaging. We are still averaging here, but think about it this way. Like average speed means average over time. Put it this way. If you got 2 exams in this class, I know I have 1 minute. If you got a 40 on one exam and a 60 on the other exam, then sure, if you average them together, you have an average of a 50. But that's not a fair representation of what's happening here. We went 40 miles an hour up a hill for a certain amount of time. Then we went 60 miles an hour down the hill for less time, right? Like we took, like, if you look at all of our numbers, it's the same hill in distance. But if you go faster, you take less time to do the same distance. So what's really, this is like, it's not like if you got a 40 on a test and a 60, it's really like if you got a 40 and a 40 and a 40 on tests, and then you got a 60 and a 60, you spent, for every 2 amount of units of time you spent getting 60, you spent 3 units of time getting 40s. It's like you got 3 40s on tests and 2 60s. If you average those together, you would add all those up and divide by 5, you get a 48. In other words, this car spent more time going 40 miles an hour than it did going 60. So of course the average is closer to 40 than it is to 60. It actually does make sense when you think about it, but that's it. You've been very patient today. I know it was a very spazzy class. I'm sorry. And I owe you stuff and I'll put up the homework and blah, blah, blah. And I'll wait for a second if there's any questions. But other than that, please go and be safe. And thank you for your indulgence. But I'm done. I'll turn off the, thank you. Thank you. All right. Thank you guys. Awesome.